All right, so here we go with translations of hyperbolas. So these are hyperbolas that do not have centers at the origin. Again, your equations should look familiar. We've just translated, we've moved the center of the hyperbola to HK instead of at the origin. And then also just please note that this here, it should be a minus sign. There was a typo in the packets that I had copied for you guys. So please just make sure that you change that in your general form box at the top of, I think it's page, I don't know, page 4, like the fourth side of a page in the hyperbola notes. Okay, so graphing when our center is not at the origin. All right, so we should be able to see from this equation that our center is at 4, comma, -1. So again, locating the center of a hyperbola is no different than it was for an ellipse or even for a circle. So 4, -1 is our center. Okay, and then keeping in mind from, or applying what we learned from when we had centers at the origin, we're going to use the information that we have in our equation up here to draw our rectangle. And also it's good to note here that x is positive, right? So our transverse axis is horizontal. So it's a horizontal transverse, which means, again, our vertices are going to be on the horizontal axis of this hyperbola. Okay, so this 4 here is telling us that from the center, we're going to go a distance of 2 units either way, right? The square root of 4 is 2, so we're going to go 2 units to the right and 2 units to the left to draw my rectangle. And likewise, the 36 is telling us how far up and down from the center to go. So we're going to go up 6 and down 6. And this is going to kind of give me the boundaries for my rectangle. Okay, so again, because we're horizontally, our transverse axis is the horizontal axis, our vertices are going to be alongside, to the left and to the right of our center. So the vertices are, so the center I'm going to do in black, the vertices, I'll do it in red, are 2, -1, and 6, -1. And again, it should make sense if we look, right? 2, -1 is 2 units from 4, -1, and 6, -1 is also 2 units from 4, -1. Okay, so we've got our rectangles. We're going to draw our diagonals and then place our hyperbola approaching those diagonals on either side. Okay, and the last, we didn't find the foci here, sorry. All right, so the foci, again, are related by that c squared equals a squared plus b squared. Okay, so c squared is going to be 40 in this case, which means that c is plus or minus 2 root 10. Okay, so now be careful though, because it's not like when we had a center at the origin where we could just say, oh, plus or minus 2 root 10. This means c tells us how far from the center, right? How far from the center are those foci? So they're plus or minus 2 root 10 from the center, which means they have coordinates 4 plus or minus 2 root 10, comma, -1, right? Because here along the foci are, the foci are going to be along this axis on the outside of the vertices. They're going to be along this axis, so they're going to have a y coordinate of -1, but they're going to have an x coordinate of 4 plus 2 root 10 and 4 minus 2 root 10. Okay, so now the last thing we need to do is write the equation for the asymptotes. Okay, so now, again, keeping in mind that we now are no longer at the center, so we don't have a y-intercept of of 0 anymore. Your best bet here is to use point-slope form. Okay, I'm going to remind you, point-slope form here. Point slope is y equals slope x minus x1 plus y1, where x1, y1 is a point on the line. Okay, so and remember that we have on both asymptotes, the center is a point on the line. Okay, so I would highly recommend using the center. And our slope is still given to us by the ratio of b to a. Right, so in this case, if we rise and run, we rise 6, we run 2. So our slope is 3 or negative 3, depending on which asymptote we're on. So plus or minus 3 is our slope. And x minus x1, if we're going to use the center, minus 4 plus y1. So the center is 4, negative 1. So plus a negative 1 or minus 1. Okay, so our asymptotes are given by the equation plus or minus 3 times x minus 4 minus 1. Okay, so again, use point-slope form. It's really not worth trying to find the y-intercept. And if you were to find the y-intercept, then you would be forced to write 2 separate equations. You wouldn't be able to do this plus or minus thing here if you use slope-intercept form, because the intercept of the positively sloped line is going to be somewhere down here, negative, and the intercept of the negatively sloped line is going to be somewhat up here, positive. So there'd be 2 completely different equations. So like I said, you're much better off just sticking with point-slope form. Oops. All right, one more example here. This is an example that is not in standard form. We're going to have to rewrite it. We're going to have to rewrite it by completing the square. So just like when we completed the square with an ellipse, we're going to have to factor, we're going to have to, take out an a value, complete the square, and make those adjustments. So it's already kind of arranged nicely for us, so I'm just going to rewrite. Actually, I'm going to go ahead and I'm going to move the 489 over, and I'm going to factor out this 4, and then I'm going to factor out the 25, right? So 4 is x squared minus 6x, and I'm going to leave that open, minus 25. Now just be careful, because unlike an ellipse, the hyperbola has this negative sign here, right? When we subtract the 25, we have to make that adjustment inside. So when we distribute negative 25, in order to get 250, we're going to want a negative 10, right? Because we need a positive 250. And leave that open, and equals 489. Okay, so to complete the square on the x's, looks like we need a 9. Okay, but again, keep in mind, we're not actually adding 9, we're actually adding 36 to this side. So we're going to have to add 36 to the right side. And to complete the square on the y's, we're going to have to add a 25. But again, we're not adding just 25. We're actually adding negative 25 times 25. So we're going to have to balance that out by adding negative 625 to the other side. Okay, so when we factor and simplify, we have 4 times x minus 3 squared minus 25 times y minus 5 squared, all equals negative 100. Okay, we need to set it equal to 1. So we're going to divide by negative 100. And notice when we divide by this negative, okay, originally our x's were positive and our y's were negative. When we divide by this negative, it's going to flip them. Okay, so I'm going to actually just rewrite it with the y's first. So we have y minus 5 squared over 4. Okay, again, it's just 25 hundredths simplified, minus x minus 3 squared over 25. So 4 100ths. Right, 4 100ths is 1/25, and that all equals 1. Okay. So from this new equation here that we have, this guy, our center is 5, comma 3. So we're going to go over 5, up 3. And our vertices, okay, are going to be along the vertical axis because y is what's positive, and they're going to be a distance of 2, right, up and down 2 from the center. Here and here. And we could draw our rectangle actually while we're at it, right? So our rectangle is going to be up vertically up and down 2 from the center, and left and right 5. Oh goodness, I'm going to run out of poor planning here. I don't have the room on my coordinate plane, but so left and right 5. 1, 2, 3, 4, 5 brings me to the axis, and then 1, 2, 3. We're gonna have to make it happen here. 4, 5. Okay, so there's our rectangle and our asymptotes. And our vertices were here and here. So our vertices are at 3, 5 and, oh, I'm sorry, 5, 5, 5, 5, and 5, 1. We could draw that hyperbola. And then find the asymptotes. So the equations for the asymptotes are going to be, looks like plus or minus 2/5. And we're going to use the center as our point in point slope form. So x minus 5 plus 3. Okay, I kind of did this out of order from where what the instructions are saying, because the last instruction is draw the 2 branches of the hyperbola. But I mean, again, I personally think it's easier to take all the information I have and put it on the graph and then kind of back into all of the other answers. It doesn't look like it asked you for foci here, but let's just for practice calculate them, keeping in mind c squared equals a squared plus b squared, right? So c squared, c being the distance from the center to the foci. So we know the foci are going to be outside, somewhere in this general vicinity and this general vicinity. Okay, so our a squared plus b squared is going to be 29, so c squared equals 29, which means that c is plus or minus 29. So the foci are, being that they're along this axis here, so their x-coordinate is going to be 5 for both of them, and their y-coordinate is going to be 3 plus root 29 and 3 minus root 29. So 3 plus or minus root 29. And that's it.